Okay, this is the next video on statics and equilibrium, and we're talking about moments today, or now. So, basically, moment is the turning effect of a force, how much it has an effect of trying to turn something. And we may as well start straight in with this because we get to it in the end. The principle of moments. If an object's in equilibrium, this word keeps cropping up now, i.e. its balance, then it has equal clockwise and anti-clockwise moments. So let's have a think about what the moment of a force is. Basically, the moment of a force is the magnitude of the force multiplied by, and this is the key word for a 2-mark question, perpendicular direction or distance. Force times perpendicular distance from the force to the pivot. So what does that really mean? Well, basically what it means is that if you've got a lever and you have a pivot point there, that's your pivot, and you apply a force F, let's say my force F is there, that's F, and this distance here is distance D, then the moment of my force, how much of a turning effect it has, is stated by the equation. Moment is force times by distance. Now, the key thing here, the thing to understand about this word here, perpendicular, is what that means is that this is assuming these two are at right angles. If they're not at right angles, you have to work out the component of the force or the component of the distance, which is perpendicular. So we're going to look at that first. Let's suppose you've got a situation where I'm going to brake, I'm going to go this way just for change. I'm going to go this way. Where I've got a lever, there it is. And I've got a hinge, let's say there's a hinge at this point here. And the lever is making an angle of, let's say that's 35 degrees against horizontal. And somebody is pushing down on this lever and applying a force downwards. Let's say the force downwards is 20 newtons. Well, what is the moment of this force? No longer, also I need to know what this length of my bar is. Let's say my bar is 2 meters long, for the sake of argument. Okay, so D is 2 meters long. So for the moment of the force, of course, the moment is the force times the perpendicular distance. But you can't say, well, it's 20 newtons times by 2 meters, because this is not a right angle up here. This is some other angle. So what we want to do is we either want to say, well, what component of this force is perpendicular? So either I want to know what this force here is, or what component of this distance is perpendicular to that force. Okay, and it makes no difference, it really doesn't matter what you do. It's in this situation, because I've drawn the angle in there, it's much easier to go, well, what's the perpendicular distance? Okay, so my force setting down there, there's an implied, if I just move my 20 newtons over, draw that going down like that, and let's just say that's 20 newtons there. There we go, now we've got a right angle. This is a distance, that's 2 meters, this is a perpendicular distance. What is the magnitude of this distance? Well, again, this is why vectors are so cool, so powerful really, for your understanding of everything to do with physics really. This is 35 degrees, so this is of course 2 cos 35, because this is the adjacent side. So now, if the moment is equal to the force times by the perpendicular distance, well, here's my moment. The force is 20 newtons and my perpendicular distance is 2 cos 35. So the moment of my force, grab a calculator, 20 times by 2 cos 35, ka-ching, is 32.733. Let's think of the units here. It's meters and it's newtons, so it's going to be Newton meters nm. Beautiful. Right, now before we sort of finish this, let's think about doing this a slightly different way. We've got to this value of 35, and I'm going to try and do it a different way. I'm going to get here again. So 33, so I get here again. I want to say, now what if we don't worry about the perpendicular distance, but let's just think about now the perpendicular force. So we've got 20 newtons this way, but I want to know what this perpendicular component is. Okay, so there we go. I've got straight away here, this angle here is 35 degrees. And a lot of students sort of struggle with this, but it becomes quite intuitive quite quickly. If this angle is 35 and this is 90, and the triangles always add up to 180, then if this is 35, this would be 90 minus 35. And if this here is perpendicular, i.e. this is a right angle, and this is 90 minus 35, then this must be 35. Ka-ching. Okay, so what you find is, oh, we've got the same situation. Before we just found, well, the perpendicular distance was 2 times cos 35. Now we want to know what the perpendicular force is. Well, it's 20 times by cos 35. So if we want to know the moment of this force, the moment of this force, well, force times by distance. Now I'm going to say, basically, I'm going to do the perpendicular force. It's going to be 20 cos 35 times by 2, and what this comes out to, I mean, I ain't going to bother solving it, but what this comes out to is 33 newtons. Again, exactly the same. So it makes no odds what you do. It's basically you just multiply by the cos 35. Okay, hopefully that makes that a bit more easy to understand.